welcome dear students. We are on the CEC Gurukul lecture and we are in the series of electronic circuit and we are discussing the electric cell. In the electric cell, we have discussed the galvanic cell, we have discussed the electrolytic cell, we have discussed the primary cell as well as the secondary cell. Reversible cell we also discussed. And we discussed the fuel cell. That is a very important nowadays, the fuel cell, and the research are going on how to improve the efficiency of the fuel cell and what fuel we can use just to get the electricity from the chemical reaction. In the fuel cell, we know that that we use the anode. That anode uses the catalyst, cause the fuel to undergo the oxidation reaction that generate the protons, that is a positively charged, and the electrons. The protons flow from the anode to the cathode through the electrolyte after the reaction, and at the same time the electrons are drawn from the anode to the cathode through the external circuit, and it produces the direct current electricity. So another is the cathode. That cathode is another catalyst that causes the hydrogen ion. So in other batteries we use other chemicals, but here in the fuel we use the fuel cell, we use the hydrogen ion, electron and the oxygen to react forming the water. So electrolyte we also use, which allows the positively charged hydrogen ions, that is a proton, to move between the two sides of the fuel cell. And we also have seen the diagram where we are having that from anode to the cathode the hydrogen atom are flowing and it produces the electricity, and these cells are having the many applications. Now the main important part of the electric cell is its capacity. What is the capacity of the cell and how much time it takes to discharge and how much usage it will be done through the cell. So the capacity of a cell is a measure in the ampere hours, that is a AH, that amperes are tells the capacity of the cell. A fully charged 50 ampere hours battery related for the cell capacity, and this fully charged 50 ampere hour battery rated for the 10-hour discharge can be discharged at the steady current of the 5 ampere for the 10 hours. Means this can be used just to discharge in a 10 hours after the 5 ampere current used and flow in it. And but if the load current is increased to the 10 ampere, then the battery is discharged in the 3 to 4 hours. That represent the capacity of the cell. Means if we talk about the 50 ampere hours battery is in demand and we use for the steady current, then it will be the 5 ampere for the 10 hours it will work. But if it is the load current, then the 10 ampere it will increase and then the discharge time will be 3 to 4 hours. Since the higher the discharge current, the lower is the effective capacity of the cell. Typically, discharge characteristics for a lead acid cell can be seen in the image. You can see here the image, you can see that here we are having a discharge time in hours, moreover the terminals PT or potential difference or the voltage which is in volts, how it is discharged. You can see here that discharge can be takes place twice discharge of twice 10 hours rate, and here we can having the discharge at the 10 hour rate. So if it is doubly used, then it is discharged in 10 hours. If it is singly used, that it in the 10 hours it will be work. So this cell capacity will let us know about the capacity of the cell, how we can use it. Means discharge capacity will let you know that what is the efficiency of this cell. Now another important term for the cell is the electromotive force of the cell. Now what is electromotive force? That we have always read in our 12th class in the BSc classes, that this electromotive force is the EMF. That EMF is the work done by the per unit charge while moving from the positive end to the negative end of the battery. That will define the EMF, and it can also be defined as the energy gain per unit charge while moving from the positive end to the negative end of the battery. So, the battery or the electric generator generates the electromotive force which causes the current to flow in the external circuit, and these devices use another form of the energy and convert them into the electric energy. So, electromotive force is the electric potential generated by the battery or any electric source which allows the current flow to in the circuit. So, electromotive force is important just to calculate the potential generated by the battery. So, any electric source while allows the current flow to the circuit because of this electromotive force. Now, you see in the diagram here you are seeing the positives at the bottom, we are having the positive one side and the negative charge another side. Now, you can see that how the EMF is moving from the positive to the negative charge and it generates the electric current. And here is a very simple circuit of generation of the EMF of the electric cell. Now, you can see this EMF is generated from positive to the negative. So, electromotive force or the EMF is calculated using the formula. We can see here epsilon, which is the electromotive force. Another is a V, that is the voltage of the battery. Another is a I, that is the current in the circuit. What is R? R is the internal resistance of the battery. So, the formula to calculate the electromotive force is epsilon is equal to V plus IR. So, the above formula is used to calculate the EMF of the battery of the cell, and the EMF of the cell is equal to the end potential difference of the cell when no current flows through the circuit. When the no current flow, what is the potential difference? That is equal to the cell EMF. Another is the combination of the electric force. How we combine the electric cell? Combination in the electric cell means we just use the 2 or 3 electric cell in the series or in the parallel combination. So, the 2 or more voltage sources are used in the different combinations to produce a desired value of the voltage and current. So, these cells can be connected in the 2 basic type of combination. So, what are these 2 basic type of combination? A are series combination and another is the parallel combination. So, these 2, first is the series combination where all the cells are arranged in the series with each other. So, a battery or a cell is a group of cell, battery is a group of cell, and the 2 cells are given which are connected in the series with each other. The negative terminal of the first cell is connected to the positive terminal of the another cell, and the other terminal are free in either of the cell. In both the cell, the other terminals are free. Now, if we talk about the series combination, then we are having a EMF as we are using the 2 cell. So, the EMF of these 2 cells are E1 and E2, and R1 and R2 its internal resistance of these 2 cells. So, if the potential at the 3 point we can calculate at A, B and C, that is denoted by VA, VB and VC, that are the potential which is generated through this EMF. Then the potential difference across these cells are given by the potential difference of these cells are given by VA minus VB and VB minus VC. you can see in the diagram then how the cells are connected in the series. So, series combination of the cell E1 and E2, you can having the R1 and R2 A, B, C. Here we are having the 2 points, and the last we are having a AC that represent the battery. So, E1 and E2 are the EMF of the 2 cell, and R1 and R2 are their internal resistance. So, now we can write it as VAB is equal to we are just calculating the 2 points VAB and VBC. So, potential at AB and BC defined as VA minus VB, which is equal to E1 minus IR1. That is simply just put the value, and another is the VB is equal to VB minus VC is equal to E2 minus IR2. Thus, the potential difference between the points A and C will be given by VA minus VC is equal to VA minus VB and minus of VC minus VB. So, VA minus VC will be, now we have the VA minus VC, all will be cancelled. So, VA minus VC is equal to E1 plus E2 minus IR1 plus IR2. So, similarly, that is the similar equation has been written again. So, to replace the combination of the cell with the single equivalent cell or the EMF value, so the equation will be E equivalent. This is represented for the single equivalent. So, single equivalent EQ minus IREQ, as we are taking the single equivalent cell of the EMF value, that is EQ. So, in respect to that its R will be changed, it will be REQ, and it is equal to E1 plus E2 minus IR1 plus IR2. That is EQ is equal to E1 plus E2 and REQ is equal to R1 plus R2. So, this can be extended if we just increase the number of cell in the series. So, that will be E equivalent is equal to E1 plus E2 and so on. Respectively, REQ will be R1 plus R2 and so on. So, a number of cells can be connected in the series, and accordingly the EMF will be changed. So, the parallel combination of the cell, another type of the combination of the cell is the parallel combination of the cell. So, a battery is a group of cells. The two cells are connected in the parallel combination of the batteries. In this combination, cell are connected in the parallel. E1 and E2, again the EMF of the two cells, moreover R1 and R2, their internal resistance. Now, this time the current flowing through the each cell is different and they are denoted by I1 and I2. In the previous, when we talk about the series, the current will be the same, but here the difference is that the current flowing in the cells are different, I1 and I2, while the total current flowing through the circuit is denoted by the I. So, I is equal to I1 plus I2 and is a sum of the both the two currents. So, you can see here, you can see easily that these are just combined in the parallel. So, parallel combination of the cell, here E1 and E2 are the EMF of the two cell as well as R1 and R2 the internal resistance. You can see A is the terminal and next terminal is the B1 and B2 and C. Now, this B1 and B2, here we have the, but in the previous we have B only. But as they are connected in the parallel combination, so we are having the B1 and B2. So, again we are having the combination. So, the final result is again the AC. Internal resistance is R1 and R2. Now, we can have the VB1 and VB2 potentials at B1 and the B2. Now, consider both the cells one by one. If it is the one cell, then V is equal to VB1 minus BV2 minus E1 minus I1R. Similarly, V is equal to B2 is equal to VB2 is equal to E2 minus I2R. So, I is equal to I1 plus I2. Now we can have I is equal to, now put the value of I, which will be E1 minus V divided by R1 plus I2 is equal to E2 minus V divided by R2. So now now we will solve it. We can have, just we open this equation, then we have I is equal to E1 by R1 plus E2 by R2 minus V into 1 by R1 plus 1 by R2. So rearranging the equation to take out the value of V, then finally we have V is equal to E1 R2 plus E2 R1 divided by R1 plus R2 plus I. As we know that this I is the I1 plus I2, we are taking the total current. So I into R1 R2 divided by R1 plus R2. To replace this combination of the cell with the single equivalent cell of the EMF value E equivalent and R equivalent, then again we have 1 by R equivalent is equal to 1 by R1 plus 1 by R2, as 1 by R1 and R2 we are taking because we are talking about the parallel combination. So E equivalent, that is in the parallel combination, we are having the E equivalent divided by R equivalent, that is equal to E1 by R1 plus E2 by R2. So these are the EMF generated that we can have. Now the another term which is used in the cell is the internal resistance of electric cell. Now when a battery falls, means it is discharged, when the battery fails, it is typically because of its build up enough internal resistance that it can no longer supply a useful amount of the power to an external load. So every cell has an internal resistance due to its resistance of the plates and the electrolyte, and that works inside a cell. So every electric cell has its internal resistance. When the cell is connected to the external circuit, current flows and there is a voltage drop across the internal resistance, and this is why potential difference is less than the EMF because of the internal resistance. Means potential difference that is generated will be less than that of the EMF. Why it is? Because of the internal resistance. So calculating the internal resistance of an electric cell when given the current, EMF and the potential difference. So R, that is the internal resistance, is equal to EMF minus PD. EMF electromotive force, PD potential difference. So we can calculate the internal resistance. Apart from this, these are the basic terms which are used: cell capacity, electromotive force, internal resistance. These are the most important part of the most important term or most important parameter of the electric cell. Another, we are talking about the advantages of the electric cell. So electric cells are light and they are portable. Moreover, they produce a very small amount of electricity, so they are perfectly safe and one can handle them without receiving the electric shocks. So they are very much easy to use, they do not give the electric shock. Moreover, they are not very costly. So they do not contain any liquid chemical that can be spilled, and they are arranged and tightly packed so that it cannot be harm to the any system. So electric cell are used in the consumer electronics, including smartphones, laptops and portable speakers, mouses, toys, and there are lots of application of such type of electric cell in many electronic appliances. So electric cell are used in the power electric vehicles nowadays, and such as the cars and the buses. Electric cells are used in the power medical services such as the pacemakers and the insulin pumps. Electric cells are used to provide the backup power to the buildings and other critical infrastructures such as hospitals and the data centers. So there are the many application of the electric cell. and these electric cell are basically used according to its applications. Now, if we talk about the electric cell, so these electric cell according to its applications, then where we can use particular cell in a particular devices. So, as the requirement of the devices, that can be used for the various gadgets and moreover the various electronic appliances. Like if we require the reversible cell, so for the reversible cell means we want to recharge, we want to charge it again and again and we will reuse it, so we use the secondary cell. If we don't want to recharge, if we use the use and throw cell, then we use the primary cell. Primary cell are less expensive than that of the secondary cell. Maintenance of primary cell are very minimum as compared to the secondary cell. So, we can differentiate between the primary cell and the secondary cell in terms of its utility, in terms of its cost. So, primary cell is used for the shorter time, but the secondary cell we can use for the longer time. Moreover, primary cell storage is very easy, but the secondary cell storage requires a particular system or a particular structure so that it can be used further. Another primary cell is also known as the dry cell, but the secondary cell is the wet cell. And moreover, there are many differences. Mechanism are irreversible or chemical reaction, and but here in the secondary cell, charging and discharging are taking place. Like from the one direction it is discharging, and from the other direction it is charging, so that it works properly. So, they are the difference between the primary cell as well as the secondary cell. Moreover, if we talk about the galvanic cell that has been used in many areas, that galvanic cell are basically based upon the half cell as well as we use the salt bridge in it. That salt bridge just used just to transfer or just for the flow of the electricity. So, a wire that is connected the two different metals, that metals are the zinc and copper, and each metal in the separate solutions just we put, and often the aqueous sulfate or the nitrate forms in the metal we put, and however the more generally the metal salts and the water which conduct the current. So, salt bridge, that is a porous membrane that used in the galvanic cell, and these are and they are kept in the solution, that is electric neutrally. So, there is that has having the another type of working conditions. So, according to its application, we use these cell in the different type of gadgets, on the different type of the circuit, according to the time, that how much time we require to discharge and charge of the discharge of this cell. So, sometimes we use the fuel cell for the conditions where we use the pure and there should not be hazardous, there is environment friendly, so we use the fuel cell. So, nowadays the fuel cell are used in the many devices. So, the research is going on how to improve the efficiency of the fuel cell, what type of material we can keep in this fuel cell. So, in the further lecture we discuss about the fuel cell and type of its. So that we can use this fuel cell uses in the various purposes. So, up to now we have discussed the electric cell, and these electric cell are used in our daily life time to time. Thank you very much.